Okay, let's look at injective functions or one-to-one functions, and we'll start by just looking at some mappings and deciding if they're functions and deciding if they're injective. Okay, so first let's recall that a function maps in one input to one output. Injective is exactly the reverse of that. Each output comes from only one input. And finally, one-to-one means it's a function and it's injective. Okay, so I know that's hard to understand there. Let's look at some illustrations with mappings. So here are three different mappings I want to analyze to sort of solidify these definitions. This first mapping sends 3 to 2 and it also sends 4 to 2. So if it's a function, then each input should have one output. Well, this input of 3 has one output and this input of 4 has one output. So it is a function. However, it is not injective because the output of 2 came from two different inputs. And since doesn't satisfy both conditions of being a function and injective, it is not one-to-one. In fact, you can see that it's 2 to 1, right? Both of these go to 1, so it's not one-to-one. The second example is not a function because the input of 2 goes to two different outputs. But it is injective because each output comes from one input. 3 comes from 2, 4 comes from 2. But again, since it does not satisfy both conditions, it is not one-to-one. In fact, you can see that it's 1 to 2 for this particular case. Finally, this last example is a function because the input of 1 goes to one output, the input of 2 goes to one output. It is also injective because we analyze the outputs. 3 comes from one input, 4 comes from one input. Since it's an injection and it's a function, it is one-to-one. So here is a good way using mappings to understand these definitions. Let's do the same thing now with two-dimensional graphs. So this first one is a function because if you pick any input, such as this x value, this input, you get a single output, right? There's no other output for that input. Same thing here, no other output except for this one for that input. So this is a function. It is not injective because if you choose this output, this y value for example, you get an input here, you get that output with this input, and you get that output with this input. So this is definitely not injective, so it is also not one-to-one. Okay, this example, this is not a function because, for example, this input has this output, and this output, those three y values, so not a function. This function, or this graph, is injective though because if you pick any output, you get a single input. So this output has one input, this output has one input, etc. There's no place where you get more than one input for an output. And finally, it's not one-to-one because it doesn't satisfy both conditions again. As you can guess, this last example is a function because if you pick an input, you get a single output no matter what input you choose. It is injective because if you choose an output, you get a single input for any output, right? So it is injective. So we have an injective function, which means that this is one-to-one. Now let's look at a couple equations and decide if they are injective. So in this example, this is a function because if you pick an x value, then you multiply that by 3 and add 6, you're going to get a number for y. So every number for x gives one number for y. Every input gives one output. This is also injective. It's hard to see maybe from the equation, but if you were to graph this, you would have a slanted line with a slope of 3, so it looks something like that. And you can imagine if you choose any output here, you would get one input. So it is injective. And finally, since it satisfies both conditions, it is one-to-one. A quadratic function, this is a function, but it's not injective, so it's not one-to-one. For example, because 2 and -2 both output 4, so 4 comes from two inputs.